Welcome to this session. In this session, we are going to cover main concepts. These are the data types, naming convention, and variables and constants. So let us see the three concepts. So let me start here with the data types. Okay, and the second one here is naming convention, and then finally the constant and variables. So as I already said, three concepts we are going to cover: data types, naming convention, and variable and constants. Okay, so what is the data types? As we already know that any data which we have, it can be numerical data, it can be for example 45, it's a numerical data. It can be say for example a name like Ali is a string value. It can be 3.68 float value. Okay, it can be true or false binary value. It can be any value between 0 to 255 or 256. Okay, this is byte value. So this one here, the first one, is an example of integer. This example of integer value. Okay, and the second one here is example of a string value. Also, we have a form that is called a char. Okay, char is an example of only single character, like A capital, for example. Then we have a float, Then we have a binary value, and this binary, it can be true, false. It can be true, false. It can be male, female, yes, no, and so forth. And then we have byte. Okay, byte, that is take any value between 0 and 255. So these are just examples of the variables which we can actually have. Of course, there are different data types. There are different data types: long integer, short integer. There are many forms of ones. Now, the main question that you might ask: why we need to define variables? Okay, in any language apart from Python, I need to write a string. For example, I have to write a string name and then to receive a value. Okay, so I need to declare clearly integer. So for integer, for example, age, that is equal whatever 23. Okay, so we need explicitly declare the data type. In Python, no, the things are different. In Python, Python, no. If I said age, the system say the variable or the container name, and then give a value. So if you give the value 45, I will know that you are integer. If you said, for example, that is whatever currency, let us say that currency, okay, you said the exchange 3.68. So now I will know that it's a float value. Why? How do you know that? Because there is a float here, there is a decimal point. In this one, there is no decimal point. If I added here, for example, for this 1.00, now it becomes a float value, is not integer. And might be you will ask yourself, what is integer? Integer, anything that should be in a discrete form. Say, for example, number of students. I cannot have 23.2 students in a class. It's illogical. The number of flight tickets should be numerical value without any float or decimal point. The number of family members, 2, 3, even 0. Okay, but you cannot have 3.5 family members. You cannot have something like this. Number of chairs. Okay, I cannot have 25.2 chairs. It's illogical. But in some other situation, I can have fractional value, float value. For example, temperature, weight, okay, height. mark. All these are examples of where I can have a decimal value. Okay. Other cases, for example, that for example with binary value. Okay. If I said, for example, pass that is equal to, I can write true. I can write actually true, or even I can write equal to as you can see, or I see here, for example, it can be path or fail. For example, if I said course status, it can be true or it can be false. So I can write either course status, as we can see here, equal to true, or I can write course status equal to 1. Both of them are the same. Or you can see course status equal to 0 or course status equal to false. So for non-passing cases. So this considered as a binary. This one is binary 4. I did not declare that this is a binary, but the system automatically discovered and detected that this is a binary value. Okay, so these are the data types as we can see here. Now, say for example, in other languages, for this one, I have to write Bool, that is Boolean, okay, and sometimes Bool, okay. For example, course status equal to true. This should be the form in other programming language, but in Python, no, this is not acceptable because Python automatically will discover and detect according to the value. Now let us look to this example. If I said, for example, here name and I said equal to 45, the computer system does not have this kind or doesn't have this kind of sensing for the semantic form. So for the system name, it's only letters, that is NAMA. So the system doesn't know that name must have actually a string value that is referred to a person or a city or something like that. No, it will accept it as a numerical value because the given value 45 is an integer, so simply it will accept it. Okay, and it shows the data type as when I print type, it shows int. Now, if I said print here, print name, okay, name, you can see there is no error. It shows 45 normally like this, okay? So this is a form of smartness actually from Python about the data types. So it can detect data according to what you give. So now if I said here in another field name equal to, say for example, Omar. So now the data type is different. Okay, so let us see the data type here. It becomes a string. Yeah, it display it without any errors in the system. Okay, so why we need again the data types? Because every data type has a different memory space and we don't like to waste the memory spaces. So we need to select or ask the system to allocate, okay, the smallest memory space that fits to each data type. So if I need integer value, then I need to have for example, integer 4 bytes. Okay, if it's a float, then 4 bytes, double 8 bytes. Okay, and the bytes, it refers to the memory space that we need to reserve to maintain this value. Here string Omar, so we need to store Omar, and here 45, we need to store 45. So what is the size, memory size that we need to allocate for this one? But of course it's not right to use name, for example, in this way. So we have to use a reference name, and this is another very important point. So a reference name, say for example, if this refers to student mark or age, so we have to write age equal to 45, and this one should be age, and this one it should be age. Why we have to use wrong naming? That will create a confusion for the human, not for the machine, for the human, and use something like this. We should use what is called a reference name. So that if you are speaking about mark, then you have to use mark. If you are speaking about salary, it's better to use salary. City, use city. Age, use age. Name, use name. Nationality, use nationality, and so forth. So try to use a variable or a container name that is related or referred to what you want to store in this variable or in this constant even. Now, the another thing that is important to cover the naming convention. So when we write, for example, the first name, okay, or let us say, for example, student name, we cannot use spaces as a variable. We cannot. So if you set, for example, a student name that is equal to input, okay, and you ask the student to enter your please enter your name. This is wrong. You receive an error because there is a space here. There is a space, and this space is not acceptable. So we have what is called naming conventions. What are the rules that we should follow when we name any variable? So you can use student underscore name like this, okay? And then you can use input. And this form here is called, this one is called a snake case. So when you use the first word, then underscore, then the second word. And the first word here is small and the second one capital or small. This is called the snake case. Now you can use, for example, a student name. This one is called camel case. So student, the first word is small and then there is no space or underscore. The second one name is written direct as. This is called the camel case. Okay. Now what if can I use all small case? Yes, student student name. I can use this for. Okay, or I can use capital student name. This for is a capital. Okay, this uppercase as we can see. Okay, now what if I use, can I use std, okay, name, can I use this for? Yes, you can use this for as abbreviation. You can use student, okay, student name. It's up to you to use any for, it's also correct, but you cannot use, you can use student one underscore a name, for example, or student one, student two. You can have a student for example, two underscore name, and so forth. So after the variable, or even you can student name one. This was also is accurate. You can use any of these. But can I use student name special character, question mark, slash, or any form? No, this is wrong. This is not correct. No, wrong. Can I use one student name with numerical value at the beginning? No, this is entirely wrong. Can I use one underscore student name? This is also no, this is entirely wrong as well. So this is known as the naming conventions. Okay, so these are the naming conventions. It's very important to be careful about how you give a name for your variables. Now, the last thing that we should cover actually the difference between variable and constant. Constant, it refers to any value that is not changeable. Okay, so we can cover this in the next session. See you in the next session.